Sir, I have seen many of videos of yours and I like them, like brain tumor, pneumonia, etc. But there is one problem. I want the same videos with Grad-CAM visualizations for brain tumors and the pneumonia to easily classify where the tumor is located. Please do this for these videos. Thank you and note it down. Hey, what's up and welcome back to the multiverse of 100 plus data science project series. And in this video, we're going to building the projects based on brain tumor as well as a Grad-CAM to localize the brain tumor in our images. Comment below your favorite project so that I can also make the tutorial on that. So without any wasting time, let's go on the Kaggle first. In order to creating the brain tumor classification projects, you're going to use in the dataset from the Kaggle that's called the brain tumor MRI images. And if I go down, we have two folders that's called the testing and the training. And using these two folder, we are going to creating our deep learning model and each of the folder having the 4 classes. Okay. And you can see on here. And also one more thing that because you're going to using here the Google Colab and try to starting this, try to calling this data set using our Google Colab, you need to create one account on that. And also you need to having one tokens or you can see the API. In order to getting the API key or you can say the token key, you need to go on your settings of the Kaggle and after that you can get the API key. Just click on this create new token. It will downloading on kaggle.json file where you have the username and your API token file. And just using this one, you can actually start in the data from the Kaggle to your Google Colab notebook. So without wasting your time, Har Har Mahadev, balka start the tutorial. Well, first thing first, I'm going to importing here the open dataset, but before that, I need to also installing this open dataset because we're going to load the dataset from the Kaggles in our workspaces. So let's say pip install open datasets. Okay, and you can using the shift enter or you can click on this button. Now you can see here requirement already satisfied on here. Okay, so now what I can do is simply going to import it here. So let's say import open data sets as OD. And inside that OD, you're going to using here the download method. So let's say download. And inside that, I'm going to pass here the link that I copied. And this is nothing but my brain tumor MRI dataset. Now you need to giving your Kaggle username and the API key. So for that, you need to go on the Kaggle website and just you need to searching for the API token and just type your username and the API key. And I'm gonna type here my username. Let's say my username. Then I'm going to give my API key. Now it will start in the dataset from the Kaggle website, and now you can see here it is downloaded, right? And if I refresh on here, you can see here my dataset is coming on here. You can see it having 2 folder, testing and the training. And if you open in this one, you can see here in the testing it having the 4 classes, and similarly for the training as well. Okay, so that's when our dataset is loaded correctly. Fine. Now what I can do, I am going to importing here some important library which one is required in order to actually building our deep learning model as well as the Grad-CAM visualization. So let's importing here first. Let's importing here the OS. Then I'm going to importing here the random, and then I'm going to importing here some of the module just like the TQDM. So let's say from TQDM import the TQDM. Why this one TQDM? Using TQDM, you can actually see the processing burst. So that's why it's easy to understand how the processing actually look like and how many time it's taken. Okay, in the form of the percentage. And after that, I'm going to importing here the most favorite library called NumPy as NP. Then import pandas as PD. Then I'm going to importing here the matplotlib.pyplot. Let's import matplotlib.pyplot as plt. Okay, and then I'm going to importing in the cb2 that's called opencb library because this is nothing but an image classification task. So you need to also load the images from the directory using the opencb, and opencb is nothing but a computer vision library, right? And then I'm going to importing here the cbond. Yeah, it's me. Yeah, cbond as SNS. Then I'm going to importing here, let's say from ipython, because you're using here the Google Colab ipython.display. We can using here import the images. Okay, image. And then I'm going to importing here the emutils. Okay, fine. Now I can using the shift enter. Now those library is imported, right? Now what I can do, I am simply going to creating here 2 directory for the cropped images, because the images you downloaded from the data set, downloaded from the Kaggles, it having some extra types of layers. I mean, extra types of background. So which one we do need to actually removing. So let's see. So here the data set in my directory, and if I go on this training and if I see the images, let's see one of the images. Let's open on here. Let's say open with photo. Okay, then you can see the image is opening on here, and you can see here it having some extra background. So we can removing this background as well, and you need to also storing these images in separate folder. So what I can do, we simply going to go on here and try to creating some directory on our workspace. Let's say os.mkdir, and inside that I'm going to save it inside the content, because this is nothing but one content. If I copy this one, just copy the path, then if I paste on here, then you can see the first thing is nothing but coming up, that's called the content. Now that's mean this workspace is nothing but slash content. So we're not also saving this, I'm not actually creating this folder just like that. So what I can do is simply going to creating here, let's say content, and then we simply going to creating here the crop brain MRI. Okay, this is nothing but my folder. Now each of the folder having different types of classes, right? So we can copy this out and we can paste it here. Okay, we can paste it here. So 4 times, because we have the 4 classes. And if I go on here, you can see we have the ZLIOMA. So ZLIOMA, it should be in a small cases. Then you have the menin, let's say menin, okay, meningioma. Then you have the no tumor, so let's say no tumor. And then you have the pituitary. Okay, so let's give it here P2ITARY. Okay, pituitary. Okay, so spelling is correct. Yeah, correct, pituitary. So we can shift enter. Now you can see here it will creating here a folder, extra folder called the crop brain MRI, and inside this folder you have the all of the classes. Okay, now similarly you need to creating here the another directory for actually testing. Okay, so let's say os.mkdir. Okay, it's nothing but for the make directory. So mkdir, and inside that it's simply going to giving here same thing content, and then you're going to using here test data, and then inside that we're also creating here the folder. Okay, so you can copy this out, we can copy this out, and we can simply going to paste it here, and we can copy this test data, and we can paste it on here. Let's say paste it on here, paste it on here, and here you go, and also here. So we're creating here the directory using this os.mkdir method. Cool. Now let's try to do some data visualizations. So let's say data visualization. Okay, so let's do it out. So for that, what I can go is simply going to creating here the list of the directory. I mean, we need to also store the path of the, let's say, train directory, and you have the test directory, right? So what I can do, you can go inside our this folder, and you can copy this path from here, copy path, and inside the train directory it should be this one, and inside the testing directory we simply going to paste here this directory path. Okay, now we have the train directory and the test directory. Now let's checking that how many classes it have. Okay, and we know that already it having just 4 classes, but it's a good choice or good practice to actually storing these classes in some kind of variable. So let's say classes equal to os.listdir, and inside that I am simply going to paste here this testing or training, whatever. Okay, let's give it here training, and then if I shift enter, and if I printing these classes, then you can see that how many classes it have. And you can see here it having the 4 classes, that's meningioma, glioma, pituitary, and the no tumor. Cool. Now we need to do the data visualization. That's mean visualize some of the data from our directory, right? So for that, what I can do is simply going to store all the file path, and from the file path we can simply going to visualize the, let's say, 10 images or 9 images, whatever, right? So for that, we're also storing this file path inside a dictionary, right? So what I can do is simply going to creating here a dictionary, let's say file path dictionary, dictionary, and then we can using here and dictionary. Now inside the dictionary we're simply going to put all of the classes, and instead of put all of the classes, and in each of the class name it having all of the images. Okay, so what I can do is simply going to, let's say, for C in classes. So let's say classes, and inside this classes, what I can do is simply going to store all of the file path in our dictionary, right? So let's say file path dictionary, and inside that is simply going to pass your C equal to, we simply going to creating here on list on that, and inside sleep we're simply going to creating here the lambda functions to iterate to all the value from our train directory based on this class name. Because we have the train directory, now if I go into this train directory, have the Ford folder, and this Ford folder name is stored inside this classes. And now inside this classes is nothing but a list, and we're simply going to iterate to all the value from here in our C. So what I can do is simply going to use the map method. So let's say map and use the lambda anonymous functions. Let's say lambda, okay, lambda x of train directory, okay, from the train directory plus C. C is nothing but this one, this classes. That's when train directory plus this one, train directory plus this one. And after that, what I can do, okay, we need to also giving here on slash on that, because we adding this out, right? So we can adding this out. Okay, then after that we're simply going to adding it here, we're simply going to adding it here the backslash. Okay, we need to adding here the backslash, adding here the backslash, and after that we need to using here plus x, and also in the lambda functions we need to also creating the list of the directory for the each of the folder. So what I can do, you can using here os dot list directory or list dir, whatever you can say. Then we can passing here our train directory plus C. Okay, now all of the data is coming inside this file path directory or dictionary. Okay, so what actually do here, we simply going to first going to iterate to all the value from the train directory. That's when we going to initialize the train directory, and also initialize here the C is nothing but the class is coming on here using the iterator. And after that we're simply going to creating here on slash, so that we can extracting the actual images from here, because using the lambda. Now inside this lambda we're simply going to creating all of the list of the images. Now all of the list with the images should be stored inside the file path dictionary. And if I shift enter, and if I printing this file path dictionary, that you can see here all of the file path of the images is coming on here. You can see here content, brain tumor MRI dataset, training, no tumor, and the images name is also added on here. Okay, now we have all of the images list in our dictionary. Now what I can do, we simply going to visualize this one. Okay, so for that what I can do is simply going to importing here one important library that's called the load images from TensorFlow. Let's say from TensorFlow dot keras dot preprocessing dot image, we are going to importing here the load image, because you need to load the images from from the directory, right? So that's why you're importing here the load images. Now we're simply going to creating here one figure. Let's say figure pld.figure, and we're simply going to giving here on fixed size of let's say 17 cross 17. And after that I am simply going to taking all of the classes and trying to do the random shuffling, because you need to also show this out. Let's say I'm going to showing here the 5 images in each of the row. So what I can do is simply going to creating here one iterator. Let's call for C in classes, because all of the classes is stored in the classes. And then I'm going to using here the random dot shuffle, so that you can shuffling this one. And from the shuffling we're simply going to take it from the file path, I mean from the actual file dictionary. We're simply going to shuffling, randomly shuffling the values based on the C, and from the shuffling of that we're simply going to take in the first 5 images. Okay, so it should be our inside the path list. Let's say path list and equal to file path dictionary, and file dictionary from C, we're taking the first 5. Okay, first 5 images we're going to taking out from here. So let's say index of 5. Now from here we're simply going to printing this out, right? So what I can do, you can using here the for loop. Let's say for I in range, because we're shuffling the images and we're taking the first 5 images from here, and we're simply going to iterate all the value from here and simply going to store it and show it in the subplot. So for that we're creating here the subplot. So let's say subplot, and inside that let's say 4,4 subplot, and inside that it's also giving here the index. So because index is coming, it's also increasing, so it also taking one variable for index. Let's say index equal to 0, and higher it will coming to this number, it will show this based on my index number. So it should be index plus equal to 1. Okay, and this index is coming on here. Okay, because based on that it will creating the index number and so many columns and so many rows it have. Okay, now you can using here plt.imshow, plt.imshow, and inside that you can using here the load images that actually created, I mean we are actually imported, and inside this load images you can giving here my path list of the I index number. Now you can giving here the title, let's say plt.title. So our title is nothing but coming from the C, this C. Okay, now what I can do, you can using the shift enter. Now you can see just white, it is loading the images from this one, and it is showing just like a visualization. Now you can see here the images. Okay, the images that you can see, it will showing here 1 2 3 4. It will showing here the 4 cross 4, 4 cross 4 matrix, or 4 cross, yeah, 4 cross 4 matrix, and each of the column and the row have the 4 images. Okay, so this is how you can actually visualize the images. Okay, that's called the data visualizations. Now let's try to checking that how many classes it have in the each of the uh, or how many images should be here in the each of the folder. Okay, so what I can do, we simply going to creating here one for loop. Let's say for I in os.listdir, and inside this listdir we simply going to giving here our the path of the training. Okay, because it will give me the list of that, right? Okay, list of that. Now you can simply going to actually taking the length of that, and how you're taking the length of that, you can see that how many images should be inside this geoloma, and how many should be in the numer, and how many should be in the pituitary. Okay, but also you know to also creating here one pie chart so that you can see the distribution of that. But how are you actually creating the pie chart, or pie chart, this kind of pie chart? It also storing some kind of data that's called number of images or the class name. So we can also do this kind of thing on here. So for that, we're actually creating here two empty list, which one is storing the number of images. So that's the number of images uh, per class, and then we have another actually list which are stored in the class name, because we're going to visualize in the pie chart. Now how you actually iterate to all the value from our training folder. So what I can do is simply going to store it inside a train class, so that you can append it, the length of the train class should be appended inside the number of images per class. I mean how many images should be in here, so that you can drawing the pie chart on here. So what I can do, you can using here os.listdir, and inside that you can using here os.path.join, and inside that you can giving here the same path, I mean this one, this path with I. Okay, same path with I, which one actually creating the list of the, let's say I. Okay, now we have the train classes. So let's say train class. Now this train class should be stored it or append it inside our no images per classes. Okay, so let's say no images per classes dot append. Okay, append the length of the, okay, length of the train class, because you're going to see that how many images should be there inside the each of the folder or each of the classes folder. So now we have this number of images per classes. Now you can also store it here the class name as well. Okay, so let's say class underscore name, because I is nothing but created a list of that. Now inside this training folder, yes, I should be the list of the name. This means it can be the xyloma, or it could be the meningioma, or the no tumor, or the pituitary. Okay, now let's append it here. Let's append the I. Okay, and after that you can also give one print statement. Let's say f string, let's say number of images in, we can give it here, let's say I, and let's say equal to the length of the train classes. You can also see this one. Okay, let's say train classes. Now you can see that how many images it have. Okay, now we have the number of images per class as well as the class name. Now we can simply go into show the pie chart. Okay, so let's say plt.figure figure, and inside that you can giving here the fixed size, let's say fixed size, and inside that you can giving here, let's say 8,8. Then after that you can creating here one colors, let's say colors equal to sns.color palette. Okay, sns.color palette, and inside that you can giving here the pastel color, so let's say pastel, and then we simply going to using here plt.pie chart. Okay, pie, and inside that you can giving here number of images per classes, and the labels we simply going to giving here the class name. Okay, let's say this is the class name, this one, and then we can giving here auto-pct. It's auto-pct is nothing but the, let's say, percentage of 1.1 f percentage, and then we can giving here the colors, and colors is nothing but our colors. Okay, now our pie chart is created. We can simply going to show this out. Let's say plt dot show. Got you. Now let's waiting for a few seconds. Now it's coming up here. Now you can see here how the pie chart is look like, and you can see this is the percentage of the glioma and the meningioma and the pituitary and the no tumor. Okay, so yeah, you can see here now the percentage of that, and we see that data set is balanced. Okay, it's not imbalanced data set. So but here is one problem, that you need to also removing this extra background from here. Okay, because this is unnecessary, fully unnecessary, because you're going to working on here. So you need to also cropping this out, right? You need to also cropping this out. So what I can do is simply going to creating here on functions to actually cropping this kind of uh, this what do you call cropping this extra background. Okay, so for that we're going to defining here on functions, and let's say crop images. Okay, and I assume that you know the OpenCV better. Okay, you have the knowledge about the computer vision, that how can you remove the extra objects from the images. Okay, let's say I am going to actually removing this background, this black background from here. So what should I need to do? Actually, first I need to actually apply here the Gaussian blur, and after that I can apply here the thresholding and the erosion and the dilation, and after that we can apply here the contours, and from the contours you simply going to actually calculate the maximum number of contours, and after that we can removing this based on the top left and right left. Okay, I mean top and the left and the right and the bottom, and simply going to starting this one. Simple. If you know the computer vision basics, it's really simple for you, because you don't have any the complex objects, just having some black background. So you can apply the contours, and based on the contours you can cropping this out. You can cropping this out. So let's try to apply it on here. So this crop image is taking one images, and we can also giving here one flag. Let's call float equal to, let's say, by default false. If the user give it float equal to true, yeah, it can be float. If you want to see this out. Okay, so what I can do, first I'm going to load the images. So I'm going to first convert this one to the CBT color, CBT color to Bezier to gray, because OpenCV read the images in the form of Beziers. So when actually passing these images, you need to pass in the images in the form of CB2 or CB2.im read in the format. This format is actually signed on here. Now inside that I need to passing here my image that is coming at the parameters, and then I need to giving here the code that's called CB2 dot color BGR to gray. Now why is there BGR? Blue, green, and the red. Why? Because OpenCV read the images in the form of BGR. Okay. Now this is my grayscale images. So let's say image gray. Now I'm going to apply here the Gaussian blur. Let's say CB2 dot Gaussian blur, and inside that blur I'm going to giving here my image gray. So let's say image gray, and then after giving the kernel, let's give here the 5x5 kernel, and sigma x, let's make it 0. We don't need it, right? So let's sign into the same variable, let's say image gray, and then we're going to apply here the thresholding. So let's use here the thresholding. Let's say cb2 dot threshold. Okay, we are going to using the thresh binary. So let's say using here image gray, or you can make it image blur, whatever you can. Okay, let's say make it image blur. Okay, let's image blur and pass it in here. Variable मतलब variable होता है ना बस. And let's give it here the minimum, let's say 45, and maximum is 2255, because we know that the maximum value of the images should be, the matrix of the images should be go on the 255, and minimum value is nothing but 0. So taking it 45, and the maximum is 255. Now we're giving here our thresh binary. So let's thresh binary. This is nothing but my code, and then we're giving here the one index 1. So this is nothing but my image threshold. Let's say image thresh, And then I'm going to apply here the erosions and the dilations. Let's say cb2 dot erode, so that you can see the contours easily. And inside that you can using here the image threshold, okay, because this is not with threshold technique as well. And let's make it none, sorry, and iterations, let's making it 2 iterations. And let's making it in the same variable name, because erosions dilations is nothing but come inside the thresholding technique. So same thing on here, let's say dilate, cb2 dot dia, okay, dilate, sorry. And then I'm going to make it, let's say, image threshold. And then same thing for here, that's a none. And then iterations is equal to 2. Okay, so you have the threshold right now. Now you can simply going to find the contours on that. So what I can do, you can using here cb2 dot find contours. Okay, find contours, aja beta, contours. And then inside that you can give in here the copy of the threshold. Don't give it here the actual images. Okay, so let's give it a copy. And after that I can using here, it's a best practice to give it a copy, okay, so that your data is not lost. Okay, let's using here the retier external, yes, retier external, yes, I am mujhe. Then you can using here the chain approx none. That's my chain approx none. This is my favorite one, chain approx none. It has same approx simplex as well. So let's say contours. Okay, so we find the contours right now. And after finding the contours, we need to taking the maximum of that. Okay, maximum of the contours. So you already actually initialize here the immutils, so you can using here the immutils, okay, immutils dot grab contours, okay, grab contours, oh aja, grab contours. Then we can passing here contours. So what it actually do, it will creating some contours on that. On here it will try to checking here all of the shapes and the contours in each of the images. After applying here this kind of technique called the Gaussian blur or the thresholding and the erosion, the dilation, you can also using here the edge detection as well. You can using in the Sobel, whatever you can actually use on here. But this is the best way to using in the, actually it have just having the two color, okay, white and the black. Okay, so this is the best choice to actually removing the background from here. So I'm going to passing here the contour. So as किधर गया, as इधर आ गया. Okay, now we grab all of the contours. So that's nothing but my contours. And now from the contours, we need to calculate the maximum of that. So what I can do is simply going to using here the max keyword, and we're simply going to give it here the contours, and inside our key we can give in here our contour area. So let's say cb2 dot contour contour area. So contour, it should be cb2 con area. Okay, it should be area. And inside that, okay, it should be the contours. I can pass it here, contour area. And inside that I need to passing, I don't need to passing it here because it's just contour area. And then we have the contours. Let's store it inside the C. And then after that, what I can do is simply going to start in the left, right, top, and the bottom. So what I can do, we can using here, let's the ext, let's say left, the left corner of the images, left corner. And what I can do, the left corner is nothing but from the minimum, and the top corner is also minimum. And while the right corner and the bottom corner is nothing but the maximum. So let's say creating here on tuple, and inside this tuple we can go on the C, and from the C we're taking all of the row, all of the column, and the zeroth index. And for the zeroth index you're taking the arg min. Okay, then we simply going to taking the first index of that. Now for here we simply going to copy this out, and then we need to using here the extra ext left to top. That's a top, and top here it should be the 1. Okay, here will be 1. Now we need to starting here the top is gone. Now it is starting here the right, so it should be right. And for the right it should be the arg max, so it should be the arg max. And we also going here the same technique for that bottom. So let's say x bottom, and here you go, you need to using here the tuple same technique, just it converting into 1, and this should be arg max. Okay, simple. Now our new image is created. Now we can actually start it inside our actual images that is coming on here. That's why taking this copy on that. So what I can do, I am simply going to, let's say, new image equal to image, okay, of the extra top of the first index to the extra of the, or axis you can say, bottom of the one, and the ext left of 0 to ext left to top, okay, left to top, or left to right, sorry, left to right, and it have be the 0. Okay, that's mean top to bottom and the left to right. Okay, so now our new image is actually created. Now we can, if the float is true, then we can float it out. That's a plt dot figure, and inside that I can giving here the fixed size of, let's say, 15,6, and then we can using here plt dot subplot, let's say 1 comma 2 comma 1, and then I can using here plt dot im show, and inside that I can passing here the images, I mean these images, because we are starting on here, and this one is nothing but my original images. So I can giving here plt dot title, and you can see the original image, let's say original image, and this new image is nothing but my cropped image. So we can taking another subplot, so let's say plt dot subplot. I don't actually comfort in the Google Colab but for the training purpose I need to using this one, because I in my machine that I'm actually using on here, you don't have any much amount of GPU, so that's why I need to choosing the Google Colab here. So let's say plt dot im show, and inside that I need to passing here the new image. So new image, then plt dot title, and inside that it into giving here, let's say, cropped image, let's say cropped image, and then we need to using here plt dot show, and after that you need to returning here, you need to return the new image. Okay, new image. Okay, so our function is ready right now. So what I can do, we can copy this one, and after that you can paste it on here. Let's taking one images from this one. Let's copy this one, copy path, and I am going to paste it here. So let's take it one variable, let's call example image. So we need to also read the images from the cb2, so that's why I'm going to using here cb2 dot imread, and inside that keeping in the path, and then I'm going to give it example images, and then I can using a float equal to true if you want to plot it out. Okay, when storing this data in our graph brain MRI, you do not actually showing this one. Okay, okay, contour area. Okay, it should be the contours area, I hope so. It should be contours area. Okay, now let's see this one. Okay, anything wrong? So c equal to max of contours, and key is nothing but cv2 dot contour area. Okay, this should be the contour area. Okay, fine. Now it's coming up. Yeah, it's coming up here. Now you can see here, this is the original images, and you can see here, this is the cropped images that you can see on here. Okay, cool, right? So let's store it into inside a variable. It should be cropped image, images. Then you can see just images as well. You don't see this ND array. Okay, so this is our original images. Now it is our cropped images. You can see how cool it is cropped in the left side and the right side. Okay, and the top and the bottom, so top and the bottom like that. Okay, so you can also test it out in more of them images. So let's try to paste it on here, and let's choose one from training. Let's choose from here. Okay, close this one and copy the path, and I'm going to paste it on here. Okay, let's paste it on here and try to checking this out. Okay, fine. Okay, you can see here cropped images. Cool, right? Now what I can do, we simply going to saving these cropped images into our folder that actually created, right? So let's try to using here, let's say saving the cropped images. Okay. Okay, further what you need to do, you need to store it into some variable. Let's say train directory plus let's say zlioma. This is nothing but my class of that, and this is my train directory. Now inside this train directory I have this class name, so it is nothing but my, let's say, gloma. Just came to creating here one variable for each of the classes. So you can copy this out and you can patch it here 4 times. So this is nothing but the menin giuma, and then copy this out and paste it here. And this one is nothing but no tumor, and this is also no underscore, let's say, tumor. And then you have the pituitary, so let's say pituitary. Okay, pituitary, uh pituitary. Okay, pituitary is nothing but go on the first. So let's try to copy this out and paste it on here, and then pituitary, and then after that we're simply going to making it the no tumor. Okay, no tumor, pituitary, and the okay, fine. Now what I can do is simply going to uh, taking all of the images from here, and after that we're going to apply here this cropped images and I store it inside our crop brain MRI folder. So for that, what I can do, we can need to using here the iterator. Let's say for I in tqdm, so that you can see the processing. Let's say os.listdir, and inside that you can give here the this variable name that actually already created here. And after that we're simply going to using here os.path.join, join the path with our the variable and with the index number. Index number is nothing but my image name, so this is nothing but my path, full path. Now this path, using this path we can simply going to read the images. So let's say image equal to cb2.im read, and inside that I can giving here the path of that. And after that we're simply going to using here this cropped image functions that we actually created or method we created, and we're simply going to making this float equal to false right now because we don't actually showing this out. That's why actually creating here this flag. Okay, and now inside that you need to giving here our images, and then if the image is not none, let's say if image is not none, if some non image is coming up, it will actually it's continue this one, or it actually it's not counting this one. Okay, it's not in. Okay, it's not in none. Then what I can do is simply going to resizing this one. Let's say cb2.resize. We simply resize it based on our model that actually using it here. We can simply going to resize it based on the 240 because the model we're going to creating on here, this shape is taken is nothing but the 240 cross 240 cross 3. Okay, so this is nothing but my images, and after that we're simply going to creating the shape path. So let's say shape underscore path, and inside the shape path we can giving here the path. You can copy this path. You can copy this path because inside this folder we simply going to store it. Then copy this path and with the images name. So let's say steer of, then you can counting this one. So let's make it here on counting. Let's say z equal to 0. So let's pass it here z, and then we can simply going to give in here our image format. Let's say jpg. Okay, that's our shape path. Now we need to also write our images using the cb2.imwrite. Okay, let's say imwrite, and inside that I can giving here my shape path, and then I can giving here my images, and after that it also uh, actually increase the value of the j. Let's say j equal to j plus 1, and that's it. Now you can see here it will loading, right? Cool. Now if I go on here and see the folder called glioma. I don't know how it actually spelling. And inside the folder you have the images or not? Yeah, we don't have any images. Okay, just because of we don't giving here one slash on here. Let's keep the slash on here. Now it actually is extracting again, and I hope so it will storing the images. Okay, So one simple mistake can ruin your life. Okay, so I actually delete this runtime, and after that I upload in the same notebook here and run it again. Okay, now you can see here inside our folder, you can see here all of the images is stored. Okay, because it will creating some problem on that, how and actually creating the classes of the variables. So that's why you need to actually removing this one, and after that you need to delete the runtime and also running this all of the code again. Okay, now you can see here this images is stored in inside the this folder, right? Now what I can do, need to do the same thing for the others one. So you can copy this one to pass it here, let's say first and second and the third time. Okay, now inside there into changing this one, let's say this is meningioma, and to pass it here, here you go, and here you go. Okay, now you to also copy this pituitary, let's say pituitary, and this pituitary and this pituitary, nothing else here. Okay, fine. And then we need to also storing this no tumor one. Okay, so let's go on here and here, and then here you go. Okay, now you can using here this shift enter. Now you can see here it is storing all of the images on here. आजा आजा बेटा, आ रहा है शायद. Cool. So all of the images is stored inside our Craft Brain AMRI folder. So now what I can do, we can checking the length of the OS dot listed of the this folder. So we can check in that how many images it have. We can see that 1 3 2 1 images it's inside each of the, it's not actually just this directory. Okay, now what I can do is simply going to do the same thing for the testing as well. So for that, you need to copy this one, we can just copy this one, and instead of this one, this train directory, you need to using the test directory. Okay, so you can copy this one, we can copy paste here, and instead of this one we can give it here, let's say test. Okay, test, and then you can using here this test, because we have also one test data folder, right? You can see test data folder, so we can give it here, let's say test pituitary, and let's say test underscore no tumor. Okay, so this is a test directory, no tumor, this one. Cool. Now what I can do, not also changing this one based on that. So this should be the test. Okay, it should be also test underscore, and then it also changing this directory name. Okay, this is the test data. Let's copy this path, and then I'm going to paste it on here. Okay, content, the test data, and this one, and the string of the j, and the same thing on here. Okay, test this one glioma, and test meningioma, and the pituitary, and the no tumor, and we have all of the classes correctly. Now we can simply go into running this shell. Okay, ठीक है ना सब कुछ? देखो देखो भाई, ठीक है ना, नहीं तो प्रॉब्लम हो जाएगा. ओके, बस हो गया. हाँ, चेक करो यहाँ पर क्रिएट हो गया डेट फोल्डर, एंड इसका बाद इसका अंदर इमेज आ गया, बस खत्म. नाउ देखो, it also do the same thing for this tree one as well. So copy this one, and I am going to paste it here. First actually changing this test data, because it's important, नहीं तो यहाँ पर शिफ्ट हो जाएगा. गूगल क्लेम में प्रॉब्लम यहाँ पर है, जो आप ऐसे डिलीट नहीं कर सकते ना. बस हो गया. ओके, तो यहाँ पर क्या करना पड़ेगा, मुझे इधर पे देना पड़ेगा टेस्ट अंडरस्कोर. तो कॉपी कर लेते इसको, लेट्स कॉपी दिस वन and paste it here. Here you go, here you go, then same thing on here and same thing on here. ठीक है ना सब कुछ, सब कुछ ठीक है. Okay, shift enter. Now you can see here the images is inside our testing folder is nothing but cropped. Okay, so it's stored inside our test data folder. Now what I can do is simply going to do the data augmentations. Okay, because we see that we have some kind of images. Okay, it's not even the last images for the deep learning, so you can also make it more using the data augmentations. So what I can do is, for that you're going to be using here the you're going to be using the image data generator from the TensorFlow. So let's import it, let's say from TensorFlow dot keras.preprocessing.image. I'm going to importing here the image data generator, and then I'm going to use here the array to images, and image to array, okay. This is nothing but for the data augmentations. Now what I can do is simply going to initialize the data augmentations, this image data generator, and inside there you can giving some rotations. That means it will rotating the images, it will do the height shift raise, and it will zoom it out, zoom in or zoom out, and it will do the horizontal flip or the vertical flip, okay. So using this one, we can actually generate some new images, and we can add it inside our this directory or inside our data set, right? Now let's try to creating the data then. Okay, so let's say data gen is equal to image data generator, okay, data generator, and inside there I need to giving here some kind of parameter, just like the rotation range. So let's say rotation range, okay, rotation range is equal to, let's say, 10. Then after that I'm going to giving here the height shift range, let's say 0.2, and then I'm going to give it here the horizontal flip. So horizontal, okay, horizontal underscore flip, let's make it true, okay. Then after that I need to give it here the validation split, let's say validation split is equal to 0.2%. 2% is nothing but for the validation split, okay. So this is nothing but called the image data generator, or you can say the data augmentations, and using this one you can creating some new kind of data. So you can add here the zoom in or zoom out or shear range, whatever you can actually add on here. So I'm just going to adding here these 4 properties on that. Now I'm going to load the data from the directory. So I'm going to using here this data then. So using data then I can flow from the directory. Let's flow from directory, and inside there I'm giving here my directory path. So I'm going to give here this crop brain MRI. So I'm going to copy path, and I'm going to give it here, and also I need to give it here my target sizes. So let's say target underscore size is nothing but the 240 cross 240, because we already resize our images in this format when you're building here our neural network using the transfer learning method. So we need to also pass in this target size, okay. And our image size is nothing but 240 cross 240 cross 3, okay. And after that I need to giving the batch size. Batch size is nothing but in a neural network how many images of batches is coming out, because in neural network you need to pass the data in the form of batch size. So let's give it the batch size of 32. That's mean 32 images should become in a once time, okay. Then after that I need to giving here the class mode. Let's say class underscore mode equal to, let's say, categorical, and then after that I need to giving here the subset. So let's say subset is equal to, let's say, training subset. Let's say training. So this is nothing but our training subset. So let's actually save it inside the train underscore data, and then we need to do the same thing for the testing one as well. So I'm going to copy this out, and I'm gonna pass it here, okay. So here you go. Then not testing actually, because we have the different types of testing data. We will do it for the validations, because you can see we give here the validation split. So it should be for the validation data. So it should be the valid data. So let's say valid data, and instead of training we need to changing this one, that's called the validation, okay. Now we need to creating another data gen for the test, okay. So what I can do is simply going to creating here, let's say, test data gen is nothing but the image data generator, okay. It should be the image data generator. So in this testing one, we do need to apply here the this rotation range, or the height shift range, or the horizontal flip, or the vertical flip, whatever, right? So we can simply going to using this data gen, okay. We can simply going to using this data gen to flow the data from the directory. Let's say flow from directory, okay, flow from directory, and then inside there we can apply it the test data as well. You can use this one test data gen, or you can also using here this data gen as well. So let's use this one, okay, so that we can get some more amount of data, and then we can using here target size. Let's say target underscore size is nothing but the that we actually talking about, let's say 240 cross 240, or in the form of tuple. Then we're giving the class mode. So let's say class underscore mode is nothing but the categorical, okay. and then after that I'm giving the shuffle equal to false, because this is the testing data, right? Now this stored it inside the variable called the test underscore data. Let's say test underscore data, and now shift enter. Then you can see how many images should be there inside each of the folder. And in the training folder, it having 3295 images belonging to 4 classes. And here we found the 822 images belonging to the 4 classes in the testing validation data. And 906 images is nothing but inside our test data. Now we can actually checking this out, this train data. Let's say this train data, I am going to use it on here, train data dot, let's say, class indices. Okay, so you can see that how many classes it have. You can see here those are the classes it's actually working on. Okay, you can checking this one, same thing for the test data at all. So you can checking this one, test data dot class, okay, class indices. You can see the same thing here. Make sure that those are mostly similar, mostly not actually, obviously similar. Okay, so we're checking this out. Yes, we got here our output. Now what I can do, we're simply going to actually plotting this out. Okay, simply going to plotting some uh, images that actually argumented. So what I can do, we can simply go into getting on plot, let's say sample of x and sample of y. Okay, sample underscore y is nothing but using the next. Just go to the folder and go to the next using the next keyword. Okay, go to the train data, because inside our train data we have all of the argumented images, right? So let's get in here and figure, let's say plt dot figure, and inside that I can give it here the fixed size. Let's give it here 12,9. Okay, then after that I'm going to using here on for loop, because I'm going to showing here the 6 images. So let's say for I in range, so let's say for I in range, and then I'm going to show this out. So let's say I need to using the subplot, right? So let's say subplot, and I'm going to show here 2 cross 3, that's means 6 images, and let's say using here I plus 1. Okay, then after that I'm going to using here sample equal to error to images that you already imported here. You can see error to images. Okay, so I'm going to using this one error to image, and inside that I'm going to passing here this sample underscore x of I. Here I have the images, and now in the samples of y, it's nothing but the samples, right? So I'm going to axis, make the axis equal to off. So okay, axis should be the off. Okay, and then I'm going to using here plt dot grid. I don't need the grid, so you can make it false. If you need it, you can make it on, right? And then after that I'm going to using here plt dot im show, and inside that I can passing here the samples, and then I'm going to using here plt dot show. Okay, so let's see that. It will load in the images. Yeah, you can see here it this is the argumented images. You can see here it will horizontal flip. Okay, and you can see here zoom range, share range, whatever. Okay, just creating some images with the by default images. Okay, predefined images. Now we're creating here our models, right? Our deep learning models. So for this case, we're going to using here the efficient net b1. And using here the efficient net b1. So let's import it here. Let's import TensorFlow. Oh, not TensorFlow STF. Then from TensorFlow dot keras dot applications, I'm gonna import here the efficient net. You can see there are so many models, you can use any of them, but I'm going to using here this efficient net b1. Then from TensorFlow dot keras dot models, I'm going to import here the model, and as well as I'm going to importing here the flattened dense layer, convolution layer, the global average polling 2D. So let's say from TensorFlow.keras.layers, I'm going to importing here the flatten, then I'm going to importing here the dense layer, then conv 2D, then we have the dropout is needed, and then the global average polling 2D. So here you go. Okay, then also importing here the optimizers called Atom. So let's say TensorFlow.keras.optimizers. I'm going to importing here the Atom. Okay, then from TensorFlow dot keras dot callbacks. I'm going to importing here the model checkpoint, then I'm going to using the earliest stopping, then I'm going to using the reduce LR on play 2, then yeah, that's it. Shift enter. Okay, you can see here all the library is imported on here. Now we can simply go into creating here our transfer learning models. So what I can do, I'm going to using here this efficient net b1, and inside that I'm going to giving here the weight is nothing but and competitions, that's called the image net competitions, and inside that I'm going to giving here include top equal to false, because we don't need the top of the layers, because we're simply going to replace it with our own classes. And then input shape, so let's say input shape is equal to, let's say 240 chord 240 cross 3. Okay, so that's our model. So what I can do, you can say that let's say ef net, oh bas khatam. Okay, then after that what I can do is simply going to use the model equal to, let's say our ef net. Okay, ef net dot our output. Okay, output, that's our model, right? Now in our model we're simply going to adding here the one layer that's called the global average pooling 2D. That's a global average pooling 2D, and the pool size we don't need to mention it here, we can simply going to pass it on here, just models. And then we're going to using here because we're going to using here the functional API, not the sequential, because this model is already created, it's all nothing but a pre-trained model. We simply do some changes on that. And then I'm going to adding here the dropout. Let's say dropout, let's say 50% of the neuron should be deactivated. Okay, and we're simply going to pass into our model. And then I'm going to add the model equal to, let's say dance layer, because this is my final layer. So I'm going to adding here the 4 classes, because we have just 4 classes that are actually working on that. And then I'm going to give it here the activations is nothing but the softmax. So let's say activation is equal to softmax, because this is an multi types of class, I mean multi-class classification types of problems. And then I'm going to pass here the model, and then I'm going to pass this model inside our model, because this model is taking first one inputs and one outputs. So input is nothing but coming from the ifinet dot input, and the output is nothing but our model. Okay, model, it should be the outputs, right? Now we can see the models right now, the model summary. So it's a model dot summary. Okay, then you can see one model, just downloaded the model from the internet, and then you can see the model. Okay, this is how the model is look like. And you can see here total parameter, how many parameter it have. The trainable parameter is nothing but 6518308. So what is actually trainable parameters? Trainable parameter is nothing but the calculations of the weight and the biases. Just mean calculate how many weight it have and how many biases it have, and then join them on. Okay, sum up, product sum it called. And non-trainable parameter is nothing but which one is not going from the training part, because we are adding here the dropout, right? And some parameter is not actually calculated. You can see 0, it's not calculated. Okay, so this is called the non-trainable parameter. Simple. If you know about the basics of the neural network, it's so easy to actually calculate that how many trainable parameter it have, right? Now what I can do, I am simply going to compile our model, because how I actually initialize your model for the training part, I mean go for the training part, obviously you need to do the compiling technique. Okay, you need to apply the compilations. So I'm going to using here the optimizer. So let's optimizer is equal to Adam, and I'm going to passing here the learning rate. That's 0.001. Okay, that's my learning rate. And then I'm going to using here loss is nothing but the categorical cross entropy. It's not a binary classification doc, like cross entropy. And then I'm going to adding here the metrics. Obviously matrix is accuracy matrix. Okay, let's say accuracy matrix. Okay, our model is compilation is should be done, but you need to also initialize here 3 more thing. One is called the model checkpoint. Okay, so it's actually used to checking for the models accuracy of the validation score, so that we don't need to train it for the multiple time. Let's say I give it here 30 epochs. Okay, if the model is not improved for the 5 times or 6 times, the accuracy is not improved, so you can stopping this one. So just called the model checkpoint. So we can using here model checkpoint. Let's say model checkpoint. So model checkpoint, and inside the checkpoint we simply going to give it here my model name. Let's say model.keras that I'm going to save on. Then I'm going to giving here monitor is equal to validation accuracy. Let's say validation underscore accuracy. And then I'm going to adding here shape based only, because I just need the shape model, best model, right? Shape based model equal to 2. And after that I'm going to giving the mode is nothing but the auto mode. Okay, auto mode में चलना चाहिए बस. इसका और क्या करना है मुझे? बर्बोस मुझे दिखना है क्या? ऑब्वियसली दिखना है मुझे. So बर्बोस चलो एक देते हैं. True, one मतलब true. So that's my checkpoint. Checkpoint. And after that I need to adding here the early stopping. Okay, so let's early stopping, and inside that I can giving here my monitor equal to validation accuracy, obviously accuracy. And then I'm going to adding here patience. Okay, not per 10 actually. Patience is equal to, let's say 5. After 5 times it will automatically stop, right? And mode is obviously R2. Okay, and then I'm going to giving the verbose equal to 1, so that you can see this one. Okay, so that's my early stopping. So let's say early stop. Okay, and then I'm going to use here the reduce. Okay, reduce. Okay, reduce LR on play 2. And then I'm going to give it here the monitor. So monitor is nothing but this monitor. बार बार क्यों टाइप करूँ भाई? इसका बाद है क्या? फैक्टर मुझे देना पड़ेगा यहाँ पर. फैक्टर है लेट्स से 0.3, 30% फैक्टर दे दो. इसके बाद पेशेंस, कितना पेशेंस चाहिए उसको? 2 देता हूँ उसको. Then let's give it here the mean delta. Delta equal to, let's say 0.001, and then mode is obviously auto. Okay, auto mode में चलना चाहिए. Okay, early stopping monitor is equal to validation accuracy, patience equal to 5, mode is auto, verbose equal to 1, and here we give it to the monitor, basically validation accuracy, and factor is nothing but 0.3. And then what we have the patience equal to 2, and mean delta is nothing but the 0.01, right? Then after that we're giving the mode is nothing but called auto, and also you need to give in the verbose, right? Verbose equal to 1, so that you can see this out. So let's run it out. Now what I can do is simply going to train our model. Okay, that's our callback. Now let's say underscore time, not underscore percent time, so that you can see the time as well. And now let's say history is equal to model dot fit, and you can passing here our train underscore data, and then you can give it epochs. Let's say epochs, let's say 30 epochs, and validation underscore data is nothing but, let's say, valid data. Okay, then you can using here verbose is equal to 1, so that you can see that. And then same thing, callbacks is equal to क्या देते हैं? Our checkpoint इसका बात है early stopping, early stop. Then you have the reduce. Okay, इसको मैंने किया क्या? Okay, नहीं किया ना. Reduce LR. So let's copy this out, and I'm going to run it here again, and then it should be reduce LR. Okay, now what I can do is simply going to cross check this one, train data, epoch 30, relations data, valid data, and the verbose is 1, callback equal to this one, and enter. Okay, it started the epochs right now. So I'll back right after when this epochs is done. 30 epochs, it maybe take half an hour, it can take. Okay, or taking the 30 minutes, whatever, right? So I'll write back after then, and then I'm going to do the predictions and also apply here this Grad-CAM. This Grad-CAM. Okay, so let's do it. Well, so it's take the 44 minutes to complete the full process, and it will take 22 epochs. And after 22 epochs, we got 98% accuracy, and validation accuracy is nothing but 99. Also, before actually training our model, we need to do some changes on here. I actually do this, unfortunately. You need to changing here one thing that's called no tumor, because I just adding here one underscore on that. So that's why some of the images is not coming up in our testing data. So that if I go on here, you can see here the number of counting images should be changes on here. it changes on here, but before that it's just nothing but 3 2 like that. So it changes, so make sure you know that, because yeah, mistake hota hai, galti se hota hai na, human error hota hai. Okay, now what I can do, I am simply going to plotting this out, plotting the graph for the training accuracy and the training loss. So what I can do, I simply going to add one figure and creating one subplot. So let's say subplots, and inside the subplots we have 1 comma 2. So 1 comma 2 means nothing but we have two plot. One is called the accuracy plot, another one is called the loss plot. Now I am simply going to giving the size of that. Let's say set, let's say x set size, okay, size in inches, and then I'm going to give it here 20 comma 8. Cool. Now what I can do, I am simply going to get this accuracy loss from this history variable, because it's saved on that. So I am going to actually give it here, let's say history dot history, and from the history I need to starting the accuracy from here. So you can see here accuracy is already suggest me. So accuracy, now we have the accuracy load stored into the variable called train underscore accuracy. And after that, it also extracting the loss, so we can copy this out and we can simply paste it here and paste it here, and oh, paste it here and paste it here. So this is nothing but the loss, so it should be my training loss. Okay, and this is nothing but my validation accuracy, it should be the val accuracy, and this is nothing but the validation loss, so it should be our val underscore accuracy, and this is nothing but the validation loss. Okay, and this one also same, let's say val underscore loss. Now I am simply going to plotting this out, but I need to plotting this out based on the epochs. Right now you can see we just give it here 30 epochs, but right now it's completed in the 20 epochs. So how can you extract them? So you can extract them using your trained data. Okay, I mean training accuracy, length of the training accuracy. So let's say epochs is equal to range of 1 comma length of train accuracy plus 1. Now you have the epochs. Now we're simply going to plot it out. So plot it out in because we have two graph, I mean two plot. So in the first plot we're simply going to plotting here our training accuracy. So let's say pld.plot, and inside that I can give it here the epochs, and then I can give it here the train accuracy. Then I can give it here one format, let's say go, that is the format of the graph. Let's say level equal to nothing but, let's say it's nothing but call the training accuracy. Okay, let's call training accuracy. Cool. And after that I'm simply going to copy this out, because I need to also adding here the validations accuracy. Okay, let's paste it here. So it should be the epochs with the validation accuracy, let's say val underscore underscore ac, and it should be changes on here, let's say y, and this is the validation accuracy, let's say validation accuracy. Cool. Now after that I can set here on title. So let's say x of 0 dot set underscore title is nothing but the model training versus model training and the validation accuracy. हो एफिलिटी से बहुत तकलीफ कर रहा है, बहुत देर से मुझे इसको रिकॉर्ड करना पड़ रहा है दिक्कत तो होता है. Okay, then we can using here lock is equal to lower right, lower right, and after that let's adding here the x level. So x underscore level, okay, it should be set x level. Okay, it should be set x level. Okay, किधर गया x level आजा, and then we can adding here the epochs. Okay, it should be epochs, and then after that you can adding here, let's say dot set underscore y level is nothing but my accuracy. Cool. Now let's try to copy this out and to do the same thing for the losses as well. So we can give it here, let's say it should be 1, because we have the two subplots. So it should be 1 1 1 and the 1. So instead of the training accuracy you can give it here the train loss. So let's say train underscore loss and the bell underscore loss. Okay, fine. Now both of the things are the same, mostly same. It should be the just training loss and the validations loss. Let's go. Here you go. And this is the loss, and you can remove in the lesion from here because you already give it here the lower right. Okay, and instead of the accuracy you can give it to the loss. you can add here the plt dot show, whatever you can let, you can using a plt dot show like this way, you can actually use on here. Okay, but if you are using the white term itself, and it will removing this text 000 point like this. Okay, just it will show the plot. Now you can see how the accuracy increases and how the loss is decreases as well. So you can add it to your thesis paper or the presentation, whatever you can add. Okay, now let's try to evaluate our model. So let's say model dot evaluate. Okay, evaluate, and inside that I can giving here my train data, because I need to evaluate our train data as well as the testing data. So it will taking time, uh taking few times. Okay, 143, just like 50 seconds it will take in that. And similarly you need to also evaluate the model for the testing data that you have. So we have the 4 classes, right? So okay, I need to wait for a few seconds. Okay, otherwise it will stopping the kernel. Okay. Okay, so now you can see here our model is evaluated correctly and we got the 99% accuracy. Now what I can do, we need to do the same thing for testing data. Let's say evaluate, and inside that you can passing here our test data. So it will also taking time for the evaluations. I hope so it will take just 14 or 15 seconds like that. Okay. Now after that, what I can do is simply going to actually predict it using our testing data, and also is simply going to show the confusion matrix and the accuracy score as well as the classification report. Yeah. So for that, it's also importing the sklearn from that. But before that, it also calculate the y predictions or y pred or the y hat, whatever you can say. Okay. So for that, we can using here model.predict, and we can taking the argmax for that. So let's say model.predict. Okay, then inside that I can giving my test data, because you need to do it for the testing data. And then we can using here the np.argmax for getting the maximum below of that. Okay, I mean that argmax. Okay, and after that I am simply going to give it the axis. So in the axis of one, in the axis of the columns, and then I'm going to store it inside a variable called y test head. Now we have the y test head. You also need the y test. So where you can get the y test, we can get it in our test data. So let's say test data dot classes. Okay, cool. Now enter, and it will predict in the y hat. Okay, it will predict this the testing data. Okay, and after that what I can do is simply go into plotting here the confusion matrix as well as the accuracy score and the classification report. So we're going to drawing here the confusion matrix in just like a plot. So for that, you're going to using the sklearn dot matrix, importing here the confusion matrix display and the accuracy score, the confusion matrix and the classification report from that. Okay, yeah, it's also completed. Okay, hoja beta hoja. Let's say from sklearn ho gaya dot matrix. I'm going to import here the confusion. Okay, confusion matrix display and the accuracy score. Okay, accuracy score आजा बस आ गया. Then confusion matrix and the classification report. Okay, and shift enter. Now let's try to display here the confusion matrix, but before that, we need to also calculate the confusion matrix using this y test and the y hat. Okay, so let's say confusion matrix. Okay, confusion matrix and y underscore test and y test hat. Okay, so what I can do, you can store it inside the cm, and after that I'm not a cm actually, just a variable name. And cm, you can see here we have the 4 classes of the confusion matrix. Now we can simply going to display this out using this confusion display, this one. So we can pass it here confusion matrix. Okay, confusion matrix is equal to cm, not minus cm. And inside the display labels, we're to giving the labels that you actually working on here. Okay, so what I can do, you can simply go taking on shell, and then say let's say test data dot class. Okay, it should be the class indices. Now you have in this one, so you can copy from here, and after that inside the classes we're simply going to patch it here. So just removing this one, because you need to also matching this one, because we're testing it out with this same what do you call same roles or same whatever you can say. Now a student variable called cm. Okay, let's say cm display display, and then you can using a cm underscore display dot plot, and then you can using a plt dot show. Bas ho gaya. Okay, then it will showing this confusion matrix in the kind of plot. Okay, you can see a plot. Okay, so this is the plot that how many is wrong classified, how many true positive, and how many true are negative. Okay, now let's do the same thing for the classification report. The classification report, so let's say y test and y test hat. Okay, and you can see here we have the classification report, but it's not in code manner. So for then into using here the print statement, and after that you can see it clearly. Okay, and you can see here how the precision and the recall look like. 0.99%, the accuracy is nothing but 90%. Okay, now let's try to do the predictions on the test images. Let's say prediction on test images. Okay, oh, image. Okay, like this. Now what I can do, for that I'm going to using here the pill library orders. Let's say import pill, and then we need to having one class dictionary. So the class dictionary is nothing but look like that, but having some changes on here. The data is data and the key should be having some mismatch. That's a class dictionary. It's nothing but I'm going to paste it here. Instead of it's a key and value, right? Key should be your number and value should be your name. So let's say one dot, and just removing this one, and it should be the two dot, and then removing this one, and third this three, this one, and removing this one from here. That's our class dictionary. Now using this class dictionary, what I can do, we simply going to iterate to all the value from the test data and try to plot it out. Okay, I mean doing this thing for the all of the images, right? You can do it for the one single images as well. So let's say for I in os.listdir, and inside that I can giving here my test data. So I can copy this out, copy path, and I'm going to paste it here. Okay, now inside this test data, what you have, we need to also having all of the images from our testing data. So let's say for item in os.listdir, okay, listdir, and inside that what I can do, we're simply going to giving here os dot path.join, and inside that I can giving here the same path. So the same path, and also I need to giving here the index number. I mean the image number is coming up on here. Now we have the actual item on here. Now we can use the pillow library to actually opening or actually reading the images. You can also using the OpenCV as well. So I'm going to using here pillow. That's a pill dot image. Okay, dot open, and then I'm going to adding here os.path.join, and inside that I'm going to give it here the path of that, and as well as I can give it here the index number and the item as well. Okay, now this is nothing but my image. So my image is coming up on here. Now I can simply go into creating one list for the images, where you can storing all of the images for the testing data. Let's say this is an empty dictionary, sorry, empty list, sorry. And then inside that I can using here, let's say images dot append the image. Now I have in the image. Now using this image I need to do the predictions. But before that, before you are not passing any data to the neural network, you're passing the data in the form of reshaping. Reshaping is nothing but the, let's say I have one images, so 1 comma 240 cross 240 cross 3. This is the process of the reshaping. That means how many images you are going to go on here. Okay, so one is nothing but the batch size, that how many images you're going to put on here. So if it is going to pass for the training loop, there should be a batch size, because you're going to do it for the one single images. So you can using here np.expand dimensions. It will automatically know that, it will automatically handle in this one. Let's expand, and we can using here the expand dimensions, and then you're going to passing here the image, and the axis is nothing but the 0. So this is nothing but my image. So this is nothing but my image, and after that I'm going to using here model.predict. Okay, now inside that I can passing here the image. That's my prediction. Let's say that's my predict. Okay, and after that we can using here the np.argmax. Let's say predict equal to np.argmax, and inside that we can passing here the predict. Cool. Now we need to also store the predictions. So let's taking on another one. Let's say predictions is equal to list, and now let us store the predictions. Let's say predictions dot append the predict. Cool. Now this predict should be get I mean path based on this class dictionary. So based on the class dictionary, so class dictionary, so predict, bus khatam. And also let's getting here another list for original, so that you can compare the original and the predicted images as well. Original image क्या था, predicted image क्या था, original dot append. अरे भाई अच्छा होगा तो हमारे thesis के लिए पास कर सकते हो, बस हो गया ना बस. So we have the images, predictions, and this one. And also what we need to do, we need to also increasing the count, right? I mean, because the images is coming up here, we need to also counting actually uh, storing this one, right? देखो काम करते हैं, इसको run करते हैं. Let's start running this out, and after that we can checking this one. Okay, is there any error or not? And now you can see here it is predicting all of the images. It will obviously taking time because all of the images is coming on here from the test data. It will testing all of the images one by one. Yeah. Okay, and after that we simply going to painting it out. Okay, I'm going to stopping the recording right now. Well, so our testing is completed. So now what I can do, we simply going to printing this out using the matplotlib. I mean visualize this one. But before that, let's try to calculate the accuracy score as well. So what I can do, we can simply going to using here the accuracy score. So let's say accuracy score, and inside that I'm going to passing here the original. I mean original list and the prediction list. Let's say prediction. And then what I can do, I am simply going to store into a variable called, let's say, a score. Okay. And then I'm going to printing this out, let's say score. And then you can getting here accuracy score is nothing but called 99%. Quite good. Now we're simply going to plotting this out. I mean plotting some of the images, testing images that actually test on here. You can also do it for one by one, or you can creating here the web applications. But मैंने बहुत बहुत web application actually बना चुका है यहाँ पर ब्रेन ट्यूमर के ऊपर, और ट्रेंडिंग टॉपिक भी है, तो आप वहाँ से फ्लक्स की मदद से बना सकते हो. ओके, मैं नहीं करूँगा क्योंकि वीडियो बहुत लंबा हो चुका है भाई, बहुत दिक्कत होता है. So let's say figure equal to plt dot figure. Then I'm using here the fixed size of, let's say, 20 comma 20. Okay, and after that what I can do, I am simply going to for I in range, let's taking the 10 images. So let's say range, and let's say 10. And after that I'm going to using here, let's say random dot randian. I'm simply going to shuffling this one, let's say random dot randian. And inside that I'm going to give it here 0 to length of the images. Okay, length of the images, I mean the images is nothing but here. Okay, so let's say images. And after that what I can do, images is nothing but our list, right? Yes, images is nothing but our list. So length of the images. Okay, so then what I can do, that's nothing but my images. I mean my images is stored into this j. And after that I'm simply going to add one subplot. So let's say pd fig, I mean figure dot add subplots. Okay, subplots. Oh, subplot, and inside that I can give it here 5 comma 2. Okay, and then I'm going to give it here I plus 1. So 5 comma 2, that's mean 5 into 2 equal to 10. That's mean you simply going to printing in the 10 images. You can print in the 20 images as well, whatever you can. Okay, it's up to you. And then after that I'm going to adding here the x label. That's a plt dot x label, and inside that I can giving here the prediction. So let's say prediction, and then I'm going to give in here spaces, and then I can plus here the prediction. Okay, of j. Then I'm going to adding here plus of the original. Let's say original is nothing but the original one. Let's say plus original. Okay, then I'm going to pass it here j. J is nothing but random images. Okay, then with the predictions, right? Now what I can do, I'm going to using here plt dot im show, and inside that I can using here image images dot into j. Okay, then after that I can using here the tight layout. Let's say figure dot tight layout, tight underscore layout. Oh, okay, then I'm going to using here plt dot show, plt dot show. Okay, so enter, shift enter, and it will running this one. It will just checking all of the images from here, randomly shuffling all the images, and after that it will actually try to printing the images from here. Okay, now you can see here, this is the images how it look like. Normal tumor, no tumor, no tumor, no tumor. Okay, quite good. not even quite good, but having some, okay, some having some space issue, so you can giving some spaces on here. Okay, then run it again. Then you can see, aja beta, aja aja. Okay, again, bas. Okay, fine. Now you can see how cool is it. It will working really fine. Pituitary, no tumor, pituitary. Okay, that's means it's really working very fine. Okay, best model build down here. Okay, now what I can do is simply going to apply here the Grad-CAM. Okay, that we actually found in the comment box, right? Well, so this is the official GitHub repository for the Grad-CAM, and this is nothing but called a beach Grad-CAM. You can learn about that how it actually work. So you can see here how the result look like. Okay, you can see the Grad-CAM result, and if I see this one, you can see here the result of this retinized cell. Hope so. You can see how it is located this affected area. Okay. Now what I can do, you can just go through all of the code and you can research on that. I'm going to go on this Grad-CAM.py. Okay, and also you can see here one nothing but one actually comment: display the Grad-CAM based on Kara's TensorFlow model using the gradient from the last convolution layer. See, last convolution layer. So these functions should work with all Kara's applications listed on here. Okay, that's mean it will working on here, and also it will returns one heat map array. Returns one heat map array, and also you can see here they're actually using here this compute the gradient. Okay, so I'm going to first copy this one, and I'm going to go on the code, and then I'm going to pass it here. Okay, just passing here the code from here. So see what actually do that. They import in CB2, NumPy, Pilu, TensorFlow, Keras, Matplotlib, and the sklearn, and as well as the TensorFlow.keras model, and it's called the models. So this is the actually nothing but how you know about that, how actually Grad-CAM actually works. Grad-CAM is nothing but the using the gradient for the last convolution layer. So last convolution layer, how can I extract them? So if I taking one shell on here, let's taking one shell and see that how can extracting it out. Let's import the TensorFlow. Let's import TensorFlow. Okay, SPF. Okay. Then what I can do, I am simply going to using here the next keyword to iterate to all the layers from our models. So what I can do, we can simply go into using here, let's say for x in models dot layers. So using models dot layer, we can actually extracting all of the layers from here. So taking all of the layer, okay, taking all of the layer of the last of the layer. From the all of the layer, we're taking the last layer, okay, last layer of the models. Now it is stored inside the x. Now how are you taking that? If the instance, okay, is instance okay, its instance is nothing but the x of TensorFlow, I mean tf dot keras dot layers. Okay, layers, it should be layers dot conv2d. If it is the convolutions layer, you can see here, if it is the gradient for the last convolutions layer, that's mean now this last convolution layer is coming up on here in the x, for x in models dot layer. Okay, and then from the layer the last one taken if it is nothing but the last convolution layer. Last convolution layer, so this is nothing but last convolution layer, right? So it's nothing but my last conv layer. Okay, okay, fine. Now what I can do is simply going to printing this out. We're simply going to printing this out. Okay, then you can see that just what you can see is the name is nothing but called top conb. Okay, we can printing, we can extracting the name from here. So this top con is nothing but my gradient layer. Here you can apply here the heat map, we can apply here the Grad-CAM. This is the code for the simple code that. Okay, इतना ये बस समझने में बात नहीं है कोई, ये बस तुम पढ़ सकते हो, यहाँ पर सब कुछ है। यहाँ पर sanity check करेगा, इसके बाद you can see last convolution layer, you calculate the last convolution layers, then target layer, original images. Okay, same thing this one. Okay, you can copy the code from here, I'll give this GitHub link. Okay, now what I can do, I am simply going to running this one, just running this one. समझने वाला कोई बात नहीं है, पर समझ सकते हो, बहुत यहाँ पर बहुत सारे ऐसे टेक्निक यूज किया है, जस्ट लाइक ऑटो ग्रेड, इफ यू नो अबाउट द पाइटर्स दैट हाउ कैन कैलकुलेट द ग्रेडियंट। ओके, डेरिवेटिव बोलता है ना, सब कुछ यहाँ पर कैलकुलेट कर चुका है यहाँ पर। ओके, तुम इसको एनालिसिस भी कर सकते हो। यू कैन आल्सो क्रिएटिंग द वेब एप्लीकेशन यूजिंग दैट। Now what I can do, I am simply going to copy this one, this which Grad-CAM, because using this one I need to actually predicting that. Okay, so inside that what I can do, I am simply going to passing here my model and my image. Okay, So my image, let's try to testing on image. Let's test image. Let's a test underscore image. So लेते हैं cv2 की मदद से, let's say cv2 dot imread, and then I'm going to give it here. Let's try to take it from, you can take it from here, or you can take it from here anywhere else. So let's taking it from here. Let's say taking from here, and I'm going to copy the first images. Let's say copy path, and then I'm going to give it to here. And after that, I need to pass it just like the image to array. So let's say image to array, and inside that I need to passing here this test image, and then I need to giving here the float results. So float results, okay, results is nothing but, let's say, true. Need to floating this out. Okay, now you can see just a white few seconds. Now it's not coming up yet. Okay, it will showing the images as well as the Grad-CAM. Okay, taking time बिकॉज बहुत सारे कंपटीशन हो रहा है। ग्रेड कैम का मतलब हमें लोकलाइज करना भाई, लोकेशन किधर है आपका, आपका जो प्रॉब्लम है ना उसका लोकेशन किधर है, तो उस लोकेशन की मदद से आपको दिख जाएगा हीट मैप की तरफ से। हीट मैप भी होता है असल में लास्ट जो कन्वोल्यूशन लेयर होता है मॉडल का, वो यू कैन यूज इट इन एनी काइंड ऑफ कैरस एप्लीकेशन, राइट? सो यू कैन सी हियर दिस प्रॉब्लम इज ऑन हियर, ओके, यू कैन सी हाउ इट इज लोकेटेड। यू कैन लेट्स से इट्स नो ट्यूमर, डोंट हैव any tumor, right? So let's try to do it for the pituitary. So copy this one, copy path, and let's try to test it on here. Okay, then you can see just a white, you can see it will taking time obviously, and I'm also using here this, you can see this tumor is coming on here. Okay, and same thing because this is a pituitary gland, right? Pituitary gland on here, and if I copy this one, let's say this from here, uh, yeah, I also know about the medical terms and technologies बिकॉज मेरा ड्रीम सपना था क्या ना डॉक्टर बनने के लिए, लेकिन गलती से मैंने इंजीनियर बन गया। ओके, यू कैन सी हियर हाउ इट एक्चुअली लुक लाइक। ओके, नो ट्यूमर, देखो नो ट्यूमर में तो नहीं होना चाहिए था, देखो टेस्ट करके दिखता है क्या होता है। गलती से ऐसे तो मैंने इंजीनियर बन गया प्रोग्रामर ही बन गया ना, इंजीनियर लाइफ। ओके, नो ट्यूमर कुछ भी नहीं है पर ऐसे, इसलिए ऐसे ऐसे दिख रहा है। तो you can also testing another one, let's say testing this one, I don't know where is it, क्या है इमेज में इसमें। ओके, इसमें थोड़ा रिमूव करके देते हैं बस। आजा ना थोड़ा, आजा आजा जल्दी से आजा भाई। ओके, so you see that how it will actually work, and how we classify the brain tumor using the efficient net b1 as well as using Grad-CAM, that how can you localize the brain tumor. Okay, so that's it for today now, and hope you enjoy this series. Also enjoy this tutorial, and make sure to subscribe the channels, share it with your friends, share it with your boyfriend, girlfriend, whatever, right? Like, comment, and subscribe. Okay, thank you and bye bye.